Hi, ladies and gentlemen. I hope everyone is doing well today. Today we're not looking at ChemQuest. I'm just going to be solving different kinds of bonding problems for you. So we start off at the top. We start off with ionic bonding. Ionic bonding are between a metal, which is positive, and a nonmetal, which is negative. Remember, the bond happens because the opposite charges attract. Just like a magnet, when you use a positive and negative side of a magnet, they stick together. So the other type of bonding is down here is covalent bonding. Covalent bonding is between two nonmetals, which are negative, and the bond happens because they share electrons. Remember, nonmetals are close, they're over here, they're close to filling the octet. Because they're close, they decide to bond with each other and just share electrons, so then both atoms can get to the full octet a little bit quicker. Also, I just want to remind you guys that this is our dividing line. Everything on this side, on the right side of the line, is a nonmetal. The only exception is hydrogen. Hydrogen is the only nonmetal on the left side of the line. So that would mean all nonmetals and hydrogen are over here. All metals are on this side. It's an ionic compound if you have one thing that's a metal and one thing that's a nonmetal. Covalent compound would be two things from this side of the line or one thing over here in hydrogen. That's how you determine whether it's ionic or covalent. So if we are solving an ionic bond, so we have two kinds of problems I can really ask. I can really ask you to name the following or to write some formulas. So when we name, you have to remember that the first ion is always positive. The second ion is negative. The first ion's name is sodium. When an atom is positive, we do not change the name. So we would just write sodium. Next, we could look at oxygen. Oxygen has a negative charge. When it has a negative charge, you have to remember to change the ending to "ide." So oxygen, we just chop off the ending, and it becomes oxide. Remember, it's not an exact science on where to chop off the word. There is a right and a wrong answer. However, what I care more about is knowing that part of the word had to be chopped off. If you gave me something like oxygen, you would still get credit for something like this. You would get credit because you still knew to chop off part of the word and add "ide." So then if we look at the next example, calcium chloride, again, the first ion is positive, so we just write calcium. Next, we have chlorine. Chlorine is negative, so we have to change the ending to "ide." So this one becomes chloride. We put it together, calcium chloride. So then next, we are writing some formulas for the following. When we write formulas, we do the crisscross method. So the crisscross method, just like it was in class, we start by writing the ion's chart, or not charge, the ion symbol and charge. Lithium is right here. Lithium is in the first column because in the first column it has a +1 charge. So we write +1. Next we have nitride. It ends in "ide, so that means you're going to find it on a periodic table, and it's a negative ion. We would come over here, you would see nitride is nitrogen. Everything in column 15 has a -3 charge. So then we would do N -3. Now we would crisscross. Remember, we don't bring the signs of the charges, we only care about the numbers. So the 1 goes here, the 3 goes there. So again, it becomes Li3N1. You can choose to leave this blank or write the 1. It's up to you. Both answers are correct. So next we would do the same thing for magnesium fluoride. We would do magnesium. You can use your periodic table. In column 2, it has a +2 charge. Next, we can look at fluorine. Remember, it ends in "ide, so we find it on the periodic table. Fluoride has a -1 charge, so we would crisscross. This 2 would go here, that 1 would go there. Remember, we don't bring the charges. So this becomes Mg1F2. Remember, you can either leave it blank or you can write the 1. It's your call. So next, we have advanced ionic bonding. So in advanced ionic bonding, we add some information on polyatomic ions. Remember, polyatomic ions are made up of many atoms. So they're made up of more than one. So if we look at some polyatomic ions, you would see here that inside the parentheses you have an ion that has more than one atom. It has more than one atom, you have 2 carbons, 3 hydrogens, 2 oxygens. Down here you have more than one atom, 1 carbon and 3 oxygens. If you looked at the examples up here, again, you only have one unique atom. So then if we're looking at the first question, down here at advanced ionic bonding, so we start by following the same rules. The name of the first atom, because it's positive, never changes. So the first example, Na, is sodium. Remember that everyone does have a list of polyatomic ions, acids, stuff that will be given to you on your quiz if you are in CP. If you are in accelerated, you will be responsible for knowing this. So we could look up and see what that guy is, C2H3O2. We look it up, we see it's acetate. So then all we need to do is write acetate, sodium acetate. Next, same thing, calcium. Calcium is positive, so we don't change the name. Next, we need to look up what carbonate is, or what CO3 is. I just told you it's carbonate. You'd see right there that it's carbonate. So you need to write carbonate, and you're just putting it together. So next we would do the same thing. When we're figuring out formulas, we use the crisscross method. So we would write magnesium, we would look up the charge based on the column it's in, +2. Sulfate ends in 8, so you would know that it's on a polyatomic ion list and not on the periodic table. So we just have to look it up. Sulfate is right here, SO4 with a -2 charge. So you write it, SO4 with a -2. Remember, when I write the charges, I write them on the outside of the parentheses. That way I remember to crisscross to the outside. We would notice that they have the same subscript, so remember when the subscripts are the same, you don't have to write them. So the answer here would be MgSO4. You could have parentheses or not have parentheses. Both are correct. So next we would do the same thing for calcium. We would write the symbol, then we would look up the charge, +2. Next, we would look up nitrate on our list, which is right here, NO3 with a -1 charge. So we write that, NO3 -1. Remember, we're still on the outside of the parentheses. Now we crisscross, 1, 2. So it goes Ca, NO3, 2. Remember to keep the subscript on the outside of the parentheses. Just like in math, we can distribute. We would multiply each subscript by 2. So you would have 6 oxygens and 2 nitrogens after you multiply. So next, we're adding transition metals. Remember, transition metals are in columns 3 through 12. So transition metals are all found throughout this area. If it's in this area, you need to include a Roman numeral. When you have a transition metal, you need a Roman numeral. The Roman numeral tells us the charge. So, if we were naming, we would name the same exact way. We would see that it's titanium and oxygen. You would come over here and you would see that titanium is in the 3 through 12. So then you know you need a Roman numeral. So then again, we would write titanium. I like to figure out my Roman numeral at the end, and then oxygen. Oxygen is on our negative side, so we change the ending to "ide." We get oxide. Now we just need to figure out the Roman numeral. So we figure out the Roman numeral of the transition metal based on what it's bound to. So we know that the charge of oxygen is -2. It's -2 because it's in column 16. Everything in column 16 has a -2 charge. So then if oxygen is a -2, remember all ionic compounds want to be neutral. What is the opposite of -2? How would we make this neutral? The opposite of -2 is +2. So then titanium 2 oxide. Next we can do the same thing. We can name everything except the Roman numeral first. So we look up nickel, or Ni. We see that it's nickel, transition metal. We need a Roman numeral. So when we start, we never change the name of the first one because it's positive. We write parentheses, leave space for our Roman numeral, and then we would see here that this is a polyatomic ion. So when we look up polyatomic ions, they're on our list. You would see that it's sulfate. So then we combine it, nickel sulfate. Now we just need to figure out the charge. We know that the charge on sulfate is a -2. and we have one of them. So we know that all of the sulfates are contributing a -2 charge. We know that we have 2 nickels, and we know that it has to be the opposite to balance out and be neutral. So we know we're looking for a +2 to make this neutral because they're opposites. So we know we have 2 nickels. So what times 2 would give us a +2? The answer is a 1, +1. So then inside the Roman numeral, we put a 1. So then next, we can use the names to come up with our formulas. So remember, the Roman numeral tells us the charge of the metal before we crisscross. So if we were to crisscross, we would write iron with a +2. It's +2 because the Roman numeral is a 2. Next, we would look up phosphate, PO4, with a -3. We look up phosphate and we find it right here. Remember to keep the charge on the outside. That way when we crisscross, you remember to crisscross to the outside. So we would get Fe3PO4 2. The next example, chromium 4 sulfate. So the 4 tells us the charge of chromium. So chromium has a +4. Next, we look up sulfate on our list right here. SO4 with a -2 charge. And now we would crisscross. Remember to keep everything on the outside of the parentheses. You would notice right now that you have a 2 to 4 ratio. You would have to remember that 2 to 4 can be reduced to 1/2. So then when we write this, it would be chromium sulfate. You would have a 1 chromium and 2 as a sulfate, just like when we reduced here. The last kind of bonding are covalent bonds. Covalent bonds are between 2 nonmetals and they share their electrons. So when we use covalent bonds, we use our prefixes. Remember, it is a covalent bond if you have 2 things on the right side of this line or hydrogen. So we use our prefixes. Again, prefixes will be given to you. You do not have to memorize them. So I guess it doesn't look good. I'll just go like this. So we use our prefixes. So remember, when we name our covalent bonds, if the subscript, so if the prefix would be greater than 1, then we would need to use a prefix. So in this case, carbon is only 1, so there is no prefix. So this one is simply carbon. We do not use the prefix mono for the first atom. We only use a prefix if it's greater than 1 for the first atom. And then next, we would add oxide. How many oxides do we have? 1. So this one would be carbon monoxide. Remember, we use the prefixes to tell us exactly how many atoms we have. So if we were to look at the second example, CCl4. Again, the first atom, we do not have more than 1. We do not have more than 1, so it's just carbon. No prefix is needed. And then next, we have chlorine. Chlorine's negative, so we change it to chloride. Now we need to figure out how many we have. We have 4. So then we can look up tetra. So then we have 4. So then it's carbon tetrachloride. So next, the other types of problems with covalent bonding that I'll ask you is going from names to formulas. So I'm going to start with the bottom one first. I start with the bottom one because you notice that this one has a prefix. So you'll know that you have 2 nitrogens. So then to write that, it would be N2. So you would see here we have 2, so then we use a prefix. We only use a prefix on the first one if it's greater than 1. So next we have oxide, so we draw our O, but how many do we have? 3. Try, so then we write 3. We do the same thing for sulfur hexafluoride. So sulfur, no mono, no prefix, so that means we have 1. Next we have fluoride, so we write our F. How many fluorides do we have? Hexa. Hexa is 6. So then this becomes SF6. So we use the prefixes to tell us exactly how many atoms we have in our formula. Remember, we only use a prefix for the first atom if it is greater than 1. I hope this helps. Remember, if you have any questions, please don't hesitate to ask. These are different types of bonding questions that you can be asked. Yeah, hope everyone has a good day.